Last time we have started with the following problem. We have a particle traveling from C to B, and they gave us that A is function of S. Last time we did the first part, we found the velocity expression. So if you remember, we used, since A is given function of S, we use the relation that is independent of time, A ds equals to V dv, and we integrated. We did this together, we obtained velocity function of S. Then we replaced for uh, S equal to 0.2 meter, which corresponds to the position of B, to find what will be S at point, uh, what will be the velocity when we reach point B. Now, uh, they also asked for the time needed to reach this position. This is why here it is a good idea to find the general form and then replacing. So I told you that sometimes you will need the relation after, because here to find the time you need to find v function of s, then say that v is what? V is ds by dt. So here, if you didn't find the general relation, you just replaced by the boundaries directly, you should again do the same work to find v function of s. This is why I told you that in some cases you might need the equation later. So this is why it's better to derive a general relation first, then replace. So now, to get s as a function of time, we separate variables. So we write that v is ds by dt, and we do separation of variables as you can see here. Now, don't worry about such functions, and I will not give you complex functions. Here it's a little bit difficult function to integrate, but you can do it if you want directly on the calculator here. And in general, I will not give you complex integration. I give you simple functions. Okay. So here we integrate for t from 0 to t at b, and for s from 0 to sb, and we can get the value of time needed to reach point. Any question on this problem? Okay. So let us continue. A particle moves along a horizontal path with a velocity of 3t squared minus 6t. If it's initially located at the origin O, determine the distance traveled in 3.5 seconds and the particle's average velocity and speed during the time interval. So here they gave us the velocity as a function of time. And we need to find what is the total distance traveled by the particle in 3.5 seconds. So if you remember when we talked about average velocity and average speed, we said that the main difference is that the average velocity only considered initial and final position, while the average speed considers the total distance of motion. So here, how to determine the total distance of motion? When you want to determine the total distance, you should know how your velocity is varying in sign, because you are interested in the change in direction. So what we will do here to be able to draw the path, so this figure is not given in the exam. We just give you the velocity function. Okay? We give you the velocity function. So you say for what values of t v is equal to 0, then you will know if I have change in direction or not. Okay, so I have here, I have the function, so I put v equal to, I can take 3t into factor, so 3t times t minus 2t, t minus 2, sorry, okay, t minus 2, and this is equal to 0 for two value, it's equal to 0 for, so I have two solutions, t equals 0 and t equals to 2 seconds. This means what? This means that initially I start from a velocity of 0, and they said that my original position was at the origin, so as well I was here at point O. Then, because it's a second degree equation and the coefficient of t square is positive, then between the two solutions I have a negative velocity between 0 and 2. And you can check if you take any time between 0 and 2, you will get a negative result. So between 0 and 2, I am going towards the left until t equal 2 seconds. And once I have t equal 2 seconds, I will change direction and continue my motion in the positive direction until the final time, which is 3.5 seconds. Now, once I have the time here, I know the time at which I change direction and the final time. All I have to do to find the distance is to determine first the coordinates at these 2 points. To find the coordinates at these 2 points, I should find s function of time, then replace. Okay? And how to find s function of time? I have v function of t. So I can say simply that v is equals v equals to ds over dt. So now if I separate variable, so ds equals to vdt, and now I can replace v by value, so by its function. V is, as we said, 3t squared minus 60 times dt. Now if I integrate the two sides, okay, I will integrate between what and what. For t, I will integrate. So here I integrate for t between 0 and t, okay? And for ds, I integrate between 0 and s. So integrate between 0, because originally at the initial state at t equals 0, I know that s is equal to 0. So I integrate between 0 and s. Okay, so if I do this, I'll obtain the following. Integral of ds is s. So s equals to s minus 0 equals to, I have here t cubed, and for 60 it's minus 3t squared. Minus 3t squared. So now this is s as a function of time. Okay, also here it's minus 0. So I get as function of time. To find s at this position, at the when I change direction, I replace t by 2. If you put t2 here, so you can find that s at 2 seconds is 2 to the power 3, which is 8, minus 3 times t to the power t squared, so minus 3 times 4, which is minus 4. So you deduce that s at 2 seconds is minus 4. And now if you want to find your final position s at 3.5 seconds, so s at 3.5 is equal to, you replace t by 3.5, you get 6.125. And always what I get is from the origin, because s is measured from the origin. So here, this is O, okay? Then when I get a negative s, I go 4 meters from O, and the positive s is 6.125 from O. Now, once I know these distances, now I can easily calculate the total distance traveled. So what is the total distance traveled? First, I'm going in this direction 4 meters. Then again, I do 4 meters. So 4 plus 4, 8. And I should add 6.125. So I can write that d total equals to 4 plus 4 plus 6.125 equals to 14.125. Another method to find the total distance, okay, you can say that the total distance is equal to another method, so is equal to delta s between 0 and 2 seconds, but I take the absolute value because the distance is positive. Okay, so I can take the absolute value of delta s between 0 and 2, between 0 and 2 seconds. okay? And plus, in the second phase from 2 to 3.5, you have a positive delta S, so no need to put absolute value. So plus delta S between 2 seconds and 3.5 seconds, okay? So, and this is equal to what? You can do it as integration. So for delta S is integral VDT, okay? So for the first part, absolute delta S between 0 and 2, it's the absolute value of integral VDT between 0 and 2, okay? So between 0 and 2. And the same for the other phase. For the other phase is plus integral VDT between 2 and 3.5 seconds. Okay? Of course, the first method is much easier. So no need to integrate, no need to do anything. I just directly look at the diagram and say it's 4 plus 4 plus 6.124. Okay? Now, in a second step, I want to calculate the average velocity. What is the average velocity by definition? V average is equal to delta S over delta T. Okay, delta S over delta T. So I just care for the initial and final position. Okay, so it's equal to, for delta S, I take S at 3.5. So S at 3.5 minus S at 0, okay, over delta T, which is 3.5 over 3.5. So I replace S as 3.5 by its value, it's 6.125, okay, minus 0. So this is delta S for the total pass over delta T, which is 3.5. And I got the average. Now to get the average speed, so the average speed, I do the function total distance over delta T over delta T. So it's equal to 14.125 plus over 3.5. And of course here, the average speed will be higher than the average velocity due to the change in direction. Okay? Any question on this? Now here, just for the total distance, if you want, let us do it in calculation. So we said it's absolute value of delta S between 0 and 2. Okay? So it is absolute value of S at 2 seconds minus S at 0 seconds. Okay? And plus for the delta S between 2 and 3.5, it is S at 3.5 minus S at 2. Okay, so if we replace, you get S2 minus S0 is minus 4, but we take the absolute value, so it's plus 4. And plus S is 3.5 minus S2, it's 6.125 minus S2 is minus 4, so minus 4, which is plus 4. So we go back to the same result, that the total distance is 14.125. Okay. Any question on this problem? Okay. So let us continue with another problem. No, just before continuing this problem. Okay. So here we will describe the graphical observations. Okay. You know that V is dF by dt. This means what mathematically? If I have as function of time, v represents the slope. Okay, v will represent the slope of curve d as function of t. So if I give you as function of time, you can deduce v function of time by just taking at any time t, you determine the slope and you determine velocity. Now, if we give us also the same between v and a, if they gave us v function of time, we can deduce a function of time because a represents the slope of v curve. Okay, because a is dv by dt. Now, if you want to work in the opposite direction, so if I give me, for example, a graph and I want to deduce v, I use the integration because delta v is integral a dt. So mathematically, the variation of v between two times, so if I have any two times t1, t2, I can say that variation delta v between t1 and t2 is equal to integral a dt, which corresponds to the area. It's like the shear and bending moment diagrams, same concept. Okay, so correspond to the area under acceleration curve. So all I need to have my graph of v is an initial condition. So if I just give me v0 at t equals 0, I can find the velocity at any other time by taking the area under the curve. Okay. Now the same between v and s. So if they give me v function of time, I can say that the variation of s between any two locations, or let's say if I know s0 given, then I can say between 0 and any time t, the variation of s is equal to the area under the v curve. Okay. Now, also I can do analysis of graphs with respect to s. If I have a function of s and I want to deduce v function of s, I go back to the relation between them. I have that half v1 square minus v0 square is equal to integral a ds. So if I have the graph a function of s, I can deduce the variation of v square. Okay. And if they give me v function of s, I can find a by saying that a is v dv by ds. So what does this mean? If I have at any position s, if I calculate v from the graph, I can read the value of v. Okay. So I read v by just doing this. I take this line, then I go to the y-axis, or here it's the v-axis. I read the value of v. Then to obtain a, I determine the slope dv by ds. So this is the slope, and I multiply velocity v by the slope dv by ds. I obtain the value of acceleration. Let us now do some problems on using the graphics. A bicycle moves along a straight road such that its position is described by the graph shown. Construct the VT and AT graphs for t varying between 0 and 30 seconds. So here we have motion described by a graph, and it is clear that we have two phases. Between 0 and 10, we have s equals 0.3 t squared, and between 10 and 30, we have s equals 60 minus 30. So first, since they gave us the equation, it's very simple. We have as function of time to find v. Okay. So first, we have two phases, so we need to find equation for two phases between 0 and 10. Between 0 and 10. Okay. We have that v is equal to ds over dt. So if you derive s with respect to time, we have s equals 0.3 t squared, so the derivative is 0.6 t. So this is v, and of course we add a constant, so plus v0. And since If they should give me an initial condition. If they don't say anything, I can consider that it's starting from rest. So if it's starting from rest, v0 equals 0. So I have 0.60. Okay. And now to find acceleration, I just say that a is equal to dv by dt. And if I derive v, I get 0.6. So I have now v and a for the first phase. Now I move to the second phase between 10 and 30. Between 10 and 30, I have that v of s is equal to 60 minus 30. Okay. So first, to find my velocity, I derive uh, s with respect to time. So I have that ds over dt is equal to 6. Okay. And to find this is equal to v. And to find my acceleration, I derive v. Since v is constant here, so my acceleration in the second phase is 0. Okay. So from here, I can draw the graphs of v and a function of time. So let us look here at the graph. So as you can see here, for the velocity, first it's a straight line variation because s was second degree. Then v becomes constant because s is linear in the second phase. Okay, and to find for a, we have a equals 0.6 here because v is linear. Then a equals 0 for the final phase. So this is the graph of acceleration. Another problem. A test car starts from rest and travels along a straight track such that it accelerates at a constant rate for 10 seconds and then decelerates at a constant rate. Draw the Vt and St graphs and determine the time t prime needed to stop the car. How far has the car traveled? So here, in this problem, they gave us a as a function of time, and they want us to deduce the graphs v function of t, as function of t, and to find the time t prime needed for the car to stop. Okay? First, we can use two methods. We can use graphical method and we can use the equation method. Let us do, if you want, both to see how both will give us the same result. So first, if I consider, here I have just 1 second. Guys, do you know how to rotate the screen? Because I don't know what happened.
Dr. Sherbile blue arrows فوق.
Which one?
The blue arrow فوق. Hat 43.
Yalla, let me change. No, it's just changing in the vertical. Look, I will try to open it again, okay?
Dr. is a tools في rotate. أو view أو edit واحدة منهم هون.
Rotate maybe. Yes, okay. Okay, thank you. Okay, so for the first phase, we have that the acceleration is equal to plus 10. Okay, so we have that for velocity, v is equal to 10t plus v0. Okay, and they said that it's starting from rest, so v0 is 0, so v is equal to 10t. Okay, now for position, I integrate another time to get s, So for S, it's 5t squared plus S0. And since they said it's starting, so when they don't give any information, I can consider that it's starting from the origin. So S0 is 0, and I have S is 5t squared. Okay? So these are the equations for the first phase. I can draw then V in the first phase is linear, and S is a second degree parabola. Okay? Now, to be able to draw, I need the final point. So I need to determine what is my final point at t equals second, at t equals 10 seconds. So just I can say from here that at t equals to 10 seconds, I have that V is equal to 10 times 10 equals to 100. Okay, and for position S is equal to 5 times 10 square, which is 5 times 100 equals to 500 meters. Okay, so these are the conditions at 10, V10, and so V at 10 and S at 10. So now I am able to draw the graphs for the first phase. Now, second step, for the second phase, what is happening? For the second phase, so from t, for t between 10 and t prime, for t between 10 and t prime, okay, what do I have? I have that acceleration becomes equal to minus 2. So for this phase, to find the velocity, I integrate a, it's minus 2t plus what, guys? أول شيء انتبهوا على شغلة. Here, t, when the phase started, t was not equal to 0. Okay, so this is, and v was not equal to 0. So I will put minus 2t, okay, plus a certain constant, and I should find what is this, what is the value of this constant. Okay, to find this constant, which boundary condition I can use?
V at 10 seconds.
Yes, exactly, because the V varies in a smooth way. Acceleration will have a jump, but V is varying in a smooth way. So I will use the boundary condition at 10 seconds. So to get the constant, I say that at t equal 10, at t equals to 10, I have that V is equal to 100. Okay, so if I replace, I get that 100 is equal to minus 20 plus the constant. So my constant for V, my constant is equal to 120. Okay, so I got the relation for V. Now, the second step, okay, is to find S. So now for S, I integrate t expression. So I have minus t squared plus 120t minus t squared plus 120 times t plus a constant. Okay, and also here to find the constant, let us call it C2. Okay, to find the constant for S, I also apply the boundary condition. So I say that at t equal 10, at t equals to 10, S is 500. So I replace to get the value of C2. So I say that that 500 is equal to minus 10 square, which is minus 100, plus 120 times 10, so plus 1200 plus C2. So now I can calculate that, I can deduce that, so C2 is equal to 600 600 minus 1200, so it's equal to minus 600. Okay, minus 600. So now once I got the equations, I can draw the graphs. Okay, and what I need to find is the value of t prime. Okay, to find the value of t prime for which the car will stop, what should I do? What equation to use?
V is equal to 0.
Exactly. So I have that I found that V is minus 2t plus the constant is 120. So here I will replace it's equal to minus 2t plus 120. Okay. So I say that to find t prime, I put this is equal to 0. So I did use that. So t prime. So t prime is equal to 60 seconds. Okay. And once I find t prime, how to find the total distance traveled? What should we do now?
Now we replace an S.
Exactly, we replace an s. Because here, why the total distance here is equal to s? Because I moved in one direction. Why? Who will tell me why I moved in one direction? مين قال لي إنه ما في change in direction?
My V equation was always positive.
Very good. My V is always positive. So I am moving in one direction, and I can say that then the total distance, so I'm moving in positive s, okay, because V is always positive. So s, since I'm started from the origin, s will represent my total distance. So all I have to do now is to replace 60 into the equation of time to get the total distance traveled. Okay. Now let us do together the graphical method. Okay, so here if you replace t by 60, you will get your total distance traveled. Let us do now the graphical method. Okay, if I want to determine graphically t prime, so let us draw together the graph of v. Okay, so this is v, this is t. I can deduce the graph of v from acceleration. How to do this? First, I'm starting from rest, so my initial velocity is 0. Okay. Now I look at A. A is constant for the first phase between 0 and 10. A is constant, so V will be linear, and the slope of V, it will have a slope equal to 10. So here I can write that the slope of the first linear phase is 10. Okay. Now how to know what is the maximum value I reach? We know that the variation in V, so I say that delta V is equal to the area under acceleration curve. And what is this area? I have a 10 times 10, so I can say that area 1 is equal to 100, okay? So I can say since I start from 0, I will reach a velocity of 100 at t equal 10 seconds. Then what will happen suddenly at 10 seconds? The acceleration will drop to -2. So the slope of velocity will drop from 10 to -2. So now I have a decreased variation. Okay. So it's decreasing. If you want to be more, to have a graph that is more representative, so I have a high slope first, a high slope, then a smaller slope after. Okay. So here the slope is +10, and here in the second phase the slope is -2. Now I know that the value here is 100, and I want to deduce what is t prime. Okay, this was the question, what is t prime? So what I can do here, if I do a small, if you want, representation, okay, V is varying from 100 to 0. So delta V of phase 2, delta V phase 2 is equal to -100. And I expect that this is due to what? This is minus A2. It is minus the area of this rectangle, because the area is below the axis, so I will take a negative, then minus a2, and the area is equal to the area of this rectangle. What is the area of this rectangle? I have the distance from here to here is t prime minus 10. So this distance is t prime minus 10, okay? And the thickness is 10. So I can say that delta V, which is minus 100, is equal to minus, to find A2, it's t prime minus 10. So t prime minus 10 times 2 times 2. Okay? So now if you solve this equation, you get that minus 100 is equal to minus 2t prime plus 20. So I have minus minus, yes, so plus 20. Now if I take 2t prime to the other side and 100 to the other side, I get that 2t prime is equal to plus 120. So t prime is equal to 60. So this is the same results I obtained from the first method. Okay, and you can see that sometimes the graphical method is very simple. So here it's very easy to get t prime using the graphical method. Now, next step, if you want to determine the total distance traveled also using graphical method, we will deduce the variation of s function of time from v function of time. Okay, so this is v function of t. If you want, let me go to the graphs, they will be more clearer than here. So this is v function of time as we did it together. Now I want to deduce the graph s function of time. Okay, so let me put it here. I want to draw now the variation of s with time. So first, what do I have? I'm starting from the origin, so at the initial state, s equal to 0. Now in the first phase, I have that v is linear increasing. Okay, so I have v positive, so s should be increasing because v is the derivative of f. Okay, v is the derivative of s, so you can say that because v initially is 0, then my initial slope, my graph will start by a slope of 0. Then as I move to from 0 to 10 seconds, my slope is increasing. So if I draw the variation of my slope is increasing. So what I deduce that I have a second degree parabola, okay, that for which the concavity is upward, because I have v linear, so s is second degree parabola, and because the slope is increasing, then if I do the representation here, I represent an upward concavity. So this is for the shape. Now, for the value I reach, when I reach this point, to know what is the value of V here, it's simply the area under V graph, okay? Because delta S is equal to the area under V, which is equal to the area of this triangle. The area of this triangle is simply 100 times 10,